So as you guys can see here, what we're doing today is we're going to be graphing log functions. So we've been dealing with logs, but you can actually graph logs if you don't have to write this, but if you think of there being like an x here and you set it equal to y, you get a bunch of coordinate pair points that go with that, and then you could plot those points and get a graph. And that's pretty much what we're going to be doing today. So first of all, let's go ahead and talk about the domain of log functions. Before we begin, that's kind of something that is a key part of graphing log functions, being aware of their domain. So first of all, what is domain? Domain is all the possible values of x. The domain of a function is all the possible values of x. There are some functions where you can't plug just anything you want to in for x. Sometimes it's not allowed. Like if you had a square root function, you can't put negatives in there, otherwise you get imaginaries. So some functions have limits on what you're allowed to have x equal. So hopefully you guys can see why that's relevant to graphing. When you're graphing, you're going to have some certain values of x and y. So you have to know what the values of x are even allowed to begin when you're graphing these. So for a log function, if you have log base b of a, let's say equals y, the a has to be greater than 0. That's something that we've talked about before with log functions. The part that comes after the base, the a value there, that has to be a positive number. It can't be 0 and it can't be negative. And that's usually where the x is going to be located, so that's going to help us find our domain. Okay. Pause there for a second in case you're still writing. All right, let's do a quick little example here. I'm going to do 2 problems here. Bless you. All right, so I want to figure out what is x allowed to be. Okay, so for logs, this piece here has to be positive. So what I'm going to do is I'm going to take just that part. The rest of it does not matter if you're trying to find the domain. All I know is that 3x minus 4 has to be greater than 0. It has to be positive. Okay? Now I want to solve for x to figure out what x would be allowed to be then. So we add 4 on both sides and divide. Just basic algebra there. And there's my domain. 4/3 as a decimal, that's about 1.3 approximately. So it says here that x has to be greater than 4/3. So can x equal 2? Yeah, because 2 is bigger than 1.3. Can x be equal to 5? Can x be equal to 0? No. Can x be equal to a half? No. Because those are both less than 1.3. So this tells me something about my log. It tells me that x has to be greater than 1.3. So now remember, our goal today is graphing log functions. Part of that process is picking numbers for x to plug in. Well, you have to know what numbers you're allowed to plug in. So that's why we're finding domain first. So now I know for this one, if I wanted to graph this, I would only be allowed to pick numbers for x that are bigger than 4/3. All right, let's do this one. Once again, we only really care about that part there that's right next to the log. It's the part that's in parentheses. I included this example because something interesting happens here. You take it and you make it greater than 0, right? We're going to solve. Let's subtract 6 on both sides first. Then I'm going to divide both sides by a -2. And this is where the interesting part happens, something you want to keep in mind. -6 divided by -2 is 3, but when you divide by a negative, that little inequality flips. That's a rule from that we've learned and used before. When you're solving for x, if you ever divide by a negative, the little arrow flips. So that's probably worth making a note of. So this is saying that x has to be less than 3. So for this function here, I'm only allowed to plug in numbers for x that are less than 3. Okay? So that's how you can find the domain of log functions. You just take the part that's after the log, make it greater than 0, and solve. Don't forget, if you have a divide by a negative, then you're going to have to reverse that inequality. Okay? All right, so we'll throw one of these your way. Okay, see what you guys got. All right, so remember our goal for today, guys, is graphing log equations, but I started here because part of the process is picking numbers for x to plug in so that you can get y values and you get points to plot and connect the dots with. You need to know what values of x you're allowed to plug in, though, because you can't just pick anything. You have to pick certain numbers. All right, so let's go ahead and begin our first graphing problem then. Now, just so you guys know, there's a lot of steps to these. So take good notes. I'll write some verbal notes as we go. I would encourage you to write those too. So here we go. Graph the log function. Okay. So step 1, you guys. Here we go. Step 1. We want to start by finding our domain. Find the domain. Okay, so that's what we just got through doing on the last example set. So you're going to take this piece here, the x minus 4. You're going to make it greater than 0, and then you're going to solve. Okay. Step 2. We're going to graph. Yeah. Oh, thank you. It should, my bad. Guys, I put 0 here, but it's supposed to be 4 because I added 4 on both sides. My bad. Thank you. All right, so step 2. We're going to graph the asymptote. Now, you probably don't know what I mean by that, but you will shortly. Graph the asymptote. So here's what I mean by that. We're going to draw a graph. My y-axis is my x-axis. The asymptote is what you got here. But I'm just going to put an equals 4 instead of a greater than 4. I'll explain why in a minute. But the asymptote is x equals 4. And what that means is that it's like a boundary that the graph can't cross, right? Remember how I said that x has to be greater than 4? So I'm going to graph an asymptote, which is a boundary that my graph cannot cross. It has to be greater than 4. So we're going to find where 4 is on the x-axis, and we're going to draw a vertical line that's dotted. That's not my graph, but that's an invisible boundary that my graph cannot cross because x has to be greater than 4. So step 1 is to find your domain. Step 2, that kind of shows you where your invisible boundary line is at. We're representing an invisible line by a dotted line. I know my graph has to be greater than 4. Now let me ask you the question. If x is greater than 4, which side of this dotted line should my graph be on? The right side or the left side? The right side, because it's greater than 4. So my graph is going to be on the right side of that dotted line. It will not exist on this left half of the graph. Okay. So step 1, find your domain. Step 2, graph that as an asymptote. All right. Step 3. This is the one that takes some work. We're going to make a table of values. All I really need to get a decent graph is about 2 points. So we want to pick any number that's bigger than 4. So I'm going to make a note of that. You won't have to write this usually, but I would encourage you guys to write this the first time. So we want to pick a number bigger than 4. So 5 maybe? Why are we picking a number bigger than 4? Because x has to be greater than 4. So we're going to pick any number bigger than 4. All right, we're going to pick another number, though. We're going to get 2 points. The next number is, I would say, make this number 10 units away from the first. I'll pause in case you guys are writing. So we could pick any other number bigger than 4, but I want to pick a number bigger than 4 that's 10 spaces away from 5. Can you guys tell me a number that's bigger than 4 that's 10 spaces more than 5? 15. Okay. Now, there's nothing magical about the number 10. But the reason why I chose it is because usually I think what most of you guys would do is you'd plug in 5 and then someone would plug in 6. And the reason why I would say don't plug in 6 is because log functions grow very slowly. They almost look flat. So if you pick two numbers that are right next to each other, it's going to look like a flat line, but it's not. If you pick a number that's really far away, you'll see, oh, it is going up a little bit. So you want to pick an x value that's far away so you can see which way the graph is actually going. So there you go. Now, it won't always be 10 more. It could be 10 less. It just depends on, is x greater than or less than. Right? All right, so this is where a lot of the work comes in here. So let me review what we've done so far, though. Find your domain, turn that into an asymptote, pick the numbers the way that we talked about. Now we got to find the y values. So let's find our y values. All right, so we're going to take our log function. Vidal, what was the function? I forgot. Is it -2? Log?
-2 log 3 times 4 plus 1.
Thank you. Equals y. All right. So we're going to plug the numbers that we picked out into this function for x. So here we go. Let's plug in 5 first. All right, so we're going to do the subtraction first. Does anybody remember what this is? Log base 3 of 1. Then a week. Let's look at this stuff. All right. It's okay. I don't want to tell you what it is right now because I want to show you a different way of doing it. But if some of you might remember the answer. This one you can do. My point is this one you could do in your head, but we're going to do it a little bit differently. All right. So the next step after you simplify inside the parentheses is we're going to use the change of base here. I want to do the change of base here, so we're going to do log over log. The 1 goes on top, the 3 goes on bottom. And this is why we got the calculators out today. So I'm going to let you guys punch that in your calculator, but don't forget to put the 1 in parentheses and the 3 in parentheses. So go ahead and type that into your calculator and see what you guys get. What'd you get, Steve?
I got
1. 1? Interesting. Yeah, it should be 0.
Do we have to put the 1 on the log?
Yeah. These big ones on the outside I don't really care about too much, but the ones on the inside you'll need for sure. So you guys should be getting 0. Now, on this one you technically didn't need to do change of base because this was one of our log properties we learned a week ago. Anytime there's a 1 here, the answer is 0. But I wanted to show you this way because usually they won't work out nice like that. And this is the strategy you'll usually have to use. All right, and so now we multiply. -2 times 0 is 0, and then 0 plus 1 is 1. So y equals 1. So I plugged in 5, and I got 1. All right, so let's go ahead and go back up to our table now. And I'm going to put 1 for y. When I plugged in 5, I got 1. What do you guys think I'm going to do next? We're going to plug in 15. So I'm going to let you guys do a lot of the work here. So I'll start us off. We're going to plug in the 15. And then I want you guys to do the first step. So go ahead and do the first step to simplifying this. So, Alondra, what goes in the parentheses here? Good. So you just do the subtraction, right? All right. See if you guys could tell me what to write next. I want to know what goes in these parentheses here. See if you could write what would go in those parentheses. What do you think, Damioni? What would go in these parentheses here? Huh? Okay. Jedrick, what do you think? Yep, change of base. Log 11 over log 3. All right, so this is where you're going to use your calculator. Don't forget your parentheses around the 11 there. Mm-hmm. Sure. All right, so I'll have to ask. I don't have my calculator, so I don't know the answer. No Cynthia today. Lily, what'd you get? Okay. That sounds reasonable to me. You guys agree? Okay. How do I know that's reasonable? Because once again, let's not forget what logs are. That means 3 to the 2.182 power is 11. I know that 3 to the second power is 9. So a little bit more would make 11 probably. So that makes sense. All right. So now we're going to do our multiplication here. And then after that, you add. So multiply that by -2 and then add 1, and we'll see what you guys get. Multiply by -2 first, and then add 1. So, Crystal, what did you get after you multiplied by 2 and added 1? Okay, that sounds reasonable. All right. So let's put that in our table. Now, when you put it in the table, we could probably just round it to, I don't know, why don't we just call it -3.5? Because when you're graphing, I mean, this is not proper rounding, really. But when you're graphing, you can't really get too precise with decimals. So we'll say 3.5. Good enough. All right. So there we go. The last step is to graph your points. So step 4, plot and connect. Plot and connect those dots together. So 5, 1. I'm going to go over 5, up 1. And then we're going to do 15 and -3.5. I need to make some space here, though. So 15, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then negative 3.5 would be like here. So we have those two dots. Okay. Now that's enough to get the graph. So you probably don't know what log functions look like yet, but I'll share that with you in a minute. But here's what we know. I know that this dot is going to connect to this dot, and then after that, it's going to keep going in that upward direction. Don't draw this, but it's going to connect, and then after that, it can't go past that line. But I'm going to make it look a little bit nicer. It's actually going to curve a little bit, and then it gets flat like that. It can't go past that dotted line, though. So since this one was lower than this dot, I knew I had to go like in an upward direction to connect them, and it keeps going in an upward direction and gets flat against that invisible barrier that it can't cross. And that's what that log function looks like. All right, it's a lot of work, a lot of steps to these. Every once in a while in math class, we get to these kinds of problems. But so hopefully you guys wrote down all the steps and the words as we went. So step 1, find your domain, plot an asymptote, make a chart and pick those numbers the way that we talked about, find the y values, and then plot your points and connect them. All right, let's go ahead and do a guided practice. That means I'm going to let you guys do each step one at a time. So number 2, here we go. Log of negative 2x minus, or say plus 4. I'll put a little 2 right there. All right. All right. So, Armani, what's the first step if I want to graph this?
Find x.
True. I'm going to say find the domain.
Oh, yeah,
But yeah, find x is right. So go ahead and do that. I'll ask you guys what you got. Haley, from the last example, do you see what the second step is? What does it say? Asymptote. Very good. We're going to graph an asymptote. So I'm going to write that. Why don't you guys go ahead and do that? Graph the asymptote. Sure. Great, thanks, sir. All right, there's your asymptote, you guys. Robin, what's the third step? Yeah, we want to make a table of values. For that one, before we get started here, we're going to pick those numbers together. All right, so Owen, I'm going to ask you a question here. What value of x would you suggest we pick first? 3? How can we pick 3? Okay. So, like the last example, remember on the last example I had x is greater than 4, so we just picked 5, the next number up, right? This one, he did the same. He picked the next number up, but we're not going to pick the next number up, and I'm going to give you a hint here, Owen. Try again. Here's your hint. 1, good. So we're doing less than 2 this time. So we have to pick numbers less than 2. So let's go ahead and do 1. All right. See if you guys can ponder a guess for the second number. I'll give you a second for that one. Why don't we share the load on this a little bit? Why don't we have this side of the room? Would you guys do the 1? Okay. And then this side of the room, would you guys do the negative 11? The chart there. So there's our values. So we have for 1, we get 0. And for negative 11, I'm just going to say negative 3.5 again. I'm just going to round it to a 0.5. I don't like the 0.7 weird numbers there. All right, let's see if you guys can graph it. Plot the points and then try to connect them and see if you can get the shape. It wasn't negative? It's positive 3.5? My bad. Sorry, guys, I made a boo-boo. I thought it was negative for some reason. It's positive 3.5. My apologies. So there's our 2 dots. And if we connect them, you can see it's going in a downward direction, and then it's going to get flat. So it's going to be like this, kind of. Okay. We'll see how the homework looks tonight. I feel like we might not have gotten to practice enough because the problems take so long. So let me have you guys try the homework out. If it looks like you're struggling a little bit, then we'll maybe practice a little more tomorrow. If not, we'll move on tomorrow. We'll see how it goes. All right. We shall stop there. Go ahead and pack on up, and we'll call it a day.